Section 5.3 of James Stewart's calculus textbook presents what's called the fundamental theorem of calculus. Now, in my opinion, the way this is worded mathematically is rather confusing. I've read it over and over and over again, and the way that they usually word it, to me, is not at all clear. It's really a very simple kind of thing. Here's what the fundamental theorem of calculus is really saying. It's saying that, basically, differentiation and integration are opposite operations. Now, if you've had calculus, or by the time you've had calculus, this should be like a overwhelmingly obvious kind of thing. But it was a big deal when it was first really solidified in the 1600s, because that's really when calculus became its own kind of discipline, when the relationship between what was being discovered with differentiation and the relationship with what was being discovered with regard to integration really were seen to be operations moving in the opposite direction. So to put it in layman's kind of terms, basically what we're saying here is that if you integrate a derivative, you're going to end up back with the original function. Now, technically there might be a constant that's added, but basically the integral of a derivative is the original function. And by the same token, the derivative of an integral is the original function. So you integrate up and then you differentiate back down, or you differentiate down and you integrate back up. But these are all kind of reversible operations, with the exception that sometimes a constant comes into play when you integrate. That's basically, of all the kind of mathematical lingo that you find in whatever part of a calculus textbook that talks about the fundamental theorem, this slide here is basically what it is all about. Now, to be a slightly more technical, but again to put it in understandable terms, the first part of the fundamental theorem of calculus is basically saying that the derivative of the integral of a function is the original function. That's what the first part is really saying. Again, it's a little bit more technical. If, say, g of x equals the integral from a to x of f of x dx, then the derivative of g of x is going to equal f of x. That's a little bit more complicated way to say it, but all it's basically saying is that the derivative of the integral of a function is the original function. Even this slide is worded more simply than the usual way it's presented in a calculus textbook, but that's what the first part of the fundamental theorem of calculus is about. The second part of the fundamental theorem of calculus is, again, it's usually not worded very clearly to me, but basically what the second part of the fundamental theorem of calculus is about is it's saying that the integral relates to the integral has to do with the antiderivatives of a function. An antiderivative is the integral of a derivative. So basically what it's saying is that the integral of a derivative is the original function. It doesn't say it very clearly. Here's how it usually says it. If basically, if the derivative of a antiderivative equals the original function, that's basically what it's saying. That the derivative of an antiderivative is the original function. Then the integral from a to b of f of x dx is going to be the antiderivative of b minus the antiderivative of a. Of the function at a and of the function at b. That is the antiderivative of the function at b and the antiderivative of the function at a. The key is, this looks obvious if you understand what a definite integral is, but basically what it's saying is that an antiderivative is what an integral is all about. So once again, the point of the second part of the fundamental theorem is to say that the integral of a derivative is the original function with perhaps a constant added. So the fundamental theorem of calculus is about the reversibility, basically, of the functions. Of going down with derivatives, you can go back up with integrals. If you go up with integrals, you can go back down with derivatives. These are inverse kinds of functions.